Welcome to Miss Perry's online physics lectures. Today's lecture will be on velocity versus time graphs. With a velocity versus time graph, calculating the slope represents a physics quantity. Since slope is equal to change in y over change in x, or rise over run, if we look at what value is on our y-axis, we see its velocity. And the value on our x-axis is time. So in calculating slope, we're actually taking change in velocity over time. So what does that slope represent? Well, the change in your velocity over time, or the rate at which your velocity changes, is your acceleration. Remember, acceleration means how many meters per second your velocity changes each second. That is your acceleration. So if I have a graph with a slope of 0, my acceleration would be 0 meters per second squared. If I have a slope with a constant positive number, I would be speeding up. If I have a slope with a constant negative number, in this case I would be slowing down because my velocity goes from some positive number to 0. Next, let's look at the area underneath a velocity versus time graph. If we take a look at that area, the shape looks like a rectangle. Well, how do we calculate the area of a rectangle? We would take length times width. Well, look at the sides of our rectangle. One side is velocity, the other side is time. So we're taking velocity times time. Well, what does that give us when we have velocity times time? If we go back to our average velocity formula, we know it's equal to displacement divided by time. If I cross multiply with that equation, I get displacement is equal to velocity times time. Well, that's what our area is. So our area in this case is equal to displacement. What this tells us is that the area underneath a velocity versus time graph equals displacement. The units for this area can be calculated the same way. Since area is velocity times time, I would take the units for velocity, meters per second, and multiply that by the units for time, seconds. Seconds will cancel out, and I'll be left with meters. The units for area underneath a velocity versus time graph are meters. Let's try a practice problem. What is Monkey Joe's acceleration at 1 second? Also, what is Monkey Joe's total displacement at 8 seconds? Take a moment to pause your video and complete the problems. Monkey Joe's acceleration at 1 second is equal to the slope of the line at 1 second. So I pick the line segment that 1 second falls on, pick 2 points on that line, and calculate the slope with change in y over change in x. If I look at that first line segment, and I use the point 0, 0, I could say, well, in 5 meters per second, that took place in a time of 1 second. 5 meters per second divided by 1 second means my acceleration is 5 meters per second squared. Every second, my velocity changes by 5 meters per second. To calculate Monkey Joe's total displacement at 8 seconds, I need to find the area underneath the graph from 0 to 8 seconds. In order to do this, I can break down that overall shape into smaller shapes and find those individual areas, and at the end add them all together. So first, I'm going to look at the area underneath the curve between 0 and 2 seconds. If I break that down into a triangle, I can use the formula for the area of a triangle, area equals 1/2 base times height, to determine that the area underneath the curve from 0 to 2 seconds is 10 meters. Next, I could look at the area underneath the curve from 2 seconds to 6 seconds. From 2 seconds to 6 seconds, I can see that the shape underneath the curve is a rectangle. I could use the formula area equals base times height to figure out that the area underneath that section of the curve is 40 meters. Next, I could break that last segment down into a rectangle and a triangle to determine that that area comprises of 20 meters and 5 meters. So overall, to find the displacement, I could add all of those individual areas together to determine that the total displacement is 75 meters. Overall, a summary of velocity versus time graphs. Big concept, slope is equal to acceleration, which means if you have a slope equal to 0, your object is not accelerating. A linear slope means your object is accelerating. And remember, the area underneath a velocity versus time graph is equal to your displacement. Any questions, comments, or concerns, please feel free to ask me during class or after school.